I appreciate you every day.
I'm just waiting for the button to break.
Alright.
There's like 3 teachers that's called me last.
Did you hear them call his license plate to the office yesterday?
You?
Yeah,
This car running.
For like 4 hours.
Oh, they didn't read it.
No,
It's just cars.
Like 30 minutes.
Alright, hey, shh. Okay. Alright,
Yeah,
hey,
his mom.
hey, here we go. Few notes today. We're on section, now this is going to seem a little funny, we're on section 6.1.
Why is that funny?
We are not finishing chapter 5, the sections that were left in it.
Oh, that's why.
We need to jump to chapter 6, which is based on the law of sine.
Oh, love that.
Okay, law of sine. I want to discuss what this is, how we're going to do it, what it means. We're still dealing with properties. The properties are still on your sheet. They're still on your property sheet. But I want to make sure that you understand where these are coming from and how they work and all that good stuff. Okay? Alright, so what this is. Just a kind of intro what we're doing here. If you had what they call... Okay, so here's my triangle. Let's call this A, B, and C.
Triangle.
A, B, and C. If you had what they call an oblique triangle.
Oblique, it means it's better than more
That
than
means it's
better.
on the side of your body.
Okay, oblique, yeah, okay. It does have to deal with sides. You are correct.
Is that an oblique or an oblique? It's larger than 90.
Okay.
That looks like theta oblique.
Okay, let's talk about this. You almost nailed it on the head. What were you saying there, Lars?
Larger than 90.
Okay, it's anything but 90 degrees. So you're close. You're really, really close. It's anything, any type of triangle.
I was thinking about obtuse.
Okay, yep, you are correct. That is the type of the triangle that I've drawn here. Any triangle that is not
What
right.
about a 12, 97, 12 triangle?
So say it again.
12, 97, and 12.
Does that add up to be 180?
No.
So,
That looks like 100.
alright, no. Alright, okay, alright.
121.
We're doing the law of sine. Now, on your property sheet, it is on there. Because the whole point of this section was to do identities, do properties about trig functions that are useful, like incredibly useful. How to find wall lengths, how to find segments, how to find angles, and to submit numbers for. Well, the question I had a couple days ago, I think it was, I don't know, it was Hall that you brought up, was why do we do this type of math? Like, what would be the purpose? How do we use a 15? How do we find the wall lengths? Okay, here's how you do it. Okay, the law of sine is the first part. Okay, here it is. This is what I want you to have. And this should be on your property sheet.
Oh, yes.
Sine of angle A over little a.
I was trying to do the other one.
Sine of angle B over little b. Sine of angle, I don't realize I had that still up. Sine of angle C over little c. This formula should be on your property sheet. I believe it's on the side with the unit circle. So turn around. Okay? Alright. But make sure you have your notes out. Let's put the bags down.
Do you want me to
Okay. Alright.
You want to put a square on that?
On squares?
put a square around that?
Yeah, hey. So, good question. You need to put a box around this formula.
Flag forward.
But it says sine A equals sine B equals sine Y. I guess a Y.
No, that's like, I think.
Or maybe you should pay attention.
That was sorry, I misprint. Oh, it's probably the angle. It's the angle in the picture. It's an actual. Yeah. So hey, if you're looking at your picture, and this was a great question somebody had, they had really goofy angles in the corners. They had theta, beta, and there's a lambda, or it's like a Y looking shape.
Lambda.
So,
You enjoy lambda.
all right.
Oh, how about a mu? How about a
What?
Put a mu in there?
Mu is one. Yeah.
There's mu there.
But
Q with
hey,
a line?
this is what I'd like you to have. So if you need to put like A's, B's, and C's next to that picture, that's fine. What I mean by this is the formula that you have, where you have angle A, you have the wall across from it, which is little a. So that's your step. Stop. Because you guys are going to be leaving here shortly. Get those bags off. All right. Okay. Little b is across, and little c is across. If you have 3 out of 4 parts you can actually solve. What I mean about 3 out of 4. If you had any type of triangle where certain numbers on the picture are given, you can find the other one. So here's what I want to discuss. Okay, I'm going to do an example of this here in a second where I just throw some numbers in here and we actually show you how to work this. It's very easy math as long as you have the angles. Then when you don't have an angle, then it gets a little more tricky. The goal today was just to introduce this, show you a couple examples, and then give you some time to work on some of the homework that you had previously assigned. Okay, so let me give some numbers here. So let's say this is 30. Let's say the wall opposite of it is 10. That works. And let's say angle B here is 130 degrees. And I want to find this, the wall that's across from it. That's where you can actually set up the proportions. Because I know a lot of people that always ask in like geometry, Ward, why can't we just do proportions for this stuff?
Because it's a
Is
curve.
it 100?
Because it's a curve. What?
Is it 100?
See that, Lars?
Or am I wrong? Because 30
Yeah.
Oh,
130 to.
maybe, we'll have to see. I don't know the number off the top of my head. I actually calculated it. Alright, but here's how it works. Okay, first step. You have to write the sine of 30. Put it over its opposite wall, which is the 10. Then the next one is sine of 130 over its opposite wall, which is the question mark. Or you could call it little b if you want. Now this is why that I always wait to do proportional stuff until we get to pre-calc, because a lot of people wouldn't know like where this comes from and all that. These formulas actually come from area formulas, how to find area of a triangle, and it's using a height, and I'll show you that probably Monday. I'll show you where all these formulas come from. The goal today was to introduce these. Okay? Yep, Sammy can sit wherever you want. Today was just kind of get us into spots and try to do some notes
It is
here.
an intro day.
Yep. All right. So when we start, when you always start proportions, you start with the number above or below your variable that you're trying to solve. You cross, multiply, and divide it. It looks like a goldfish. I know it's silly. That's what I always call it fish method. But you're taking sine of 130 times the 10, and then you're going to divide
By
by
30.
sine of 30.
Yeah.
Now, you have to make sure that you're typing these in. Like some of the calculators, you might have to actually find these first before you actually type it. You have to use a lot of parentheses when you're actually doing these. Like if I were to type this in, this is what I would actually type. I type in 10 times the sine of 130, and this will require that I close the parenthesis on that one. Then when I hit the division sign, I need to make sure there is parentheses around this whole piece. I have to divide the whole thing on the top by the sine of
Or
30.
you could just hit equal.
Or yeah, or hit equal so you actually get the number for the top. Then divide that answer by sine of 30 and close that parenthesis. But my answer, whatever it is, it's definitely larger than 10. You know,
15.
like Josie, you even said like, was it 100 or something? I don't know what the number is. I know it's got to be significantly larger than 10.
15.32.
Okay, it's larger. Okay, so say the number again.
15.32.
0.32. Is that what kind of everyone's getting?
Yeah.
Okay, so it had to be larger. I didn't know if it was gonna be 100. I didn't know it because we just kind of made up the numbers. But that number makes sense. The reason why that number makes sense to me, it's definitely bigger than 10. This is the largest side. And why I know this is the largest side, one of the properties in geometry says the bigger the angle, the bigger the wall in a triangle.
I get it.
They're actually proportional to each other. And this is the actual setup for how you do proportions. A lot of people just want to do this. 130 over the x, 30 over 10. You can't do that. The reason why is what we said earlier. When you do sine and cosines, they're based on curves. They're based on a circular path around an object. Because when you actually looked at the unit circle, that's why they give you decimals and fractions. And you can't set up this type of work because this is using straight lines and we're actually doing curves for the trig functions. So that's why we have to do sine, because it's adjusting the triangle for what we have. But again, why this works is because of the relationship of walls in triangles. Now I know that when you look at that, you're like, Ward, those are not right triangles. How are you doing sine and cosines and all that? Because what it actually does is it actually breaks up your picture into right triangles, and then it's combining it automatically for you. There's a pretty long process to prove that this does work. We'll look at that on Monday when we have more time. The goal today was not to do that. It was to show you how to use it, how easy it is, because that is simple. It's very, very easy. And then the whole goal is to show you what a difficult problem would be. And then that's it. That's where I want to stop today. It's pretty straightforward.
So C's gonna be the biggest wall,
Yeah.
right?
So this wall was the largest wall. This will be the smaller angles. So,
How
okay.
do we always draw the, I thought you said, since, we always draw our angles in the circle, and you said, and you just said that we can't.
For what?
That's the unit circle thing?
Yeah.
We always draw our angles in there.
I think what Lars is
No,
trying
I
to
mean-
say is C would be the biggest wall.
No, that's not what I'm trying to say. Shut up. No, we always draw angles in here, don't we?
Well, when you're starting, you put that first wall on the x-axis, then you open up counterclockwise, so we go 130. So you'll be in that second quadrant where that final wall would be sitting. Does that help you out?
So he's saying
Okay.
C is not the biggest wall.
All right.
I always thought though that C was A squared plus B squared.
No, we're not doing right triangles and stuff. No. I see what you're saying. No.
No, I was just saying that like.
Yeah, so
normally
that,
B
I
would
think
be
that's
right
what
with
Lars is
C.
trying to get at, that C is usually the biggest
Yeah,
wall.
not in this case because they're oblique, so we're not going to have like that same set of drawings. All right. Last problem that I want to talk about today. Last one. How do we find an angle? So let's say that we had letter C here. Let's say it's 11. I'll just say it's bigger than the other one. Okay. And why I know this is a triangle? We said this was 15.32. So the trick is one of the rules that we learn in geometry class is that any two walls you pick have to be more than the third wall when you add them together. So no matter which two walls you pick on this picture, they have to add to be more than the third wall that's compared to it. So I could not have a 5 sitting here. Because if I add it to the 10, it won't be more than that wall. It would have to be more than 5.32. Maybe it would be 5.33, and I'd be safe. It could be up to 6. I could go up as far as having this number be as large as 25. But I don't want to go past 25, or not 25, but 15. The reason being is that when you add these two together, they have to be more than that wall. So there's a limitation what this number can be. 5.33 up to, 15, roughly? It's got to be less than 15.32. It's got to be in between here, I'll say 15.3. The reason why it had to be in between, because when you add those two, they have to be more than that one. So there's a limitation to wall lengths. Okay, last step here. To find the missing angle, I want to find angle C. It's pretty easy. What do triangles have to add up to be?
180.
180.
So it's
Okay.
50, right?
So, last one, not 50. This would have to be 20. Now, to show that the math can actually work, how you can actually find it. Now, I don't know if this is an actual 11. I don't know if that's the actual correct number. Let's just say it's 11. And I'm going to ignore all these other numbers here. So I'm going to get rid of these other ones. Let's leave the 10. Let's get rid of the 130
So
here.
far we have.
Okay, we can find numbers. Now, I don't know if this will actually work out to be 20 because I'm making up these numbers. But you're going sine of 10. And then on this next part, you're going to put an 11 down here. And I need to find the angle on the top. The angle that's across from it. Now, again, this is a brand new problem. It's not based on the last one. So I'm not going to guarantee this will be 20 because I'm making up the 11. 730. So again, brand new problem. So if you're redrawing this, I'm not doing the same exact triangle, so I don't know what angle B is anymore. But I want to find angle C, this one. So when you do this problem, this is the part you have to have sitting here. And this is the part that a lot of people always get wrong. The C is the angle I'm missing. That's what I'm trying to find.
Yeah. Fish method.
So you have to do fish method, but it's going to be equal to sine of C. So you always have to start with the number above or below your variable.
Won't we?
You cross, multiply, and divide, and then, so this is 11 times the sine of 30 over 10, because you divided by 10, and this whole thing is equal to sine of C. And that's the part people forget. They forget like there's a sine C sitting there, not just a variable like x.
So do we have to take the inverse?
Yeah, we'll have to do the inverse sine button. So we have to figure out what this number is. This should be a
0.55, I
decimal.
bet.
So, say it again?
0.55. So-
555.
So will it be
No, just-
21? Just 0.55.
Say again, what was the question? What was the question somebody had? Sorry. I didn't
Will
catch
it be 21?
I'll see or something.
I don't know. I don't know what the angle would be. So, all right. But anyways, what we have here, we have the 50 0.55. we take the inverse sine to the other
And you
side.
get 33.367.
Okay, fair enough. Because the inverse sine of 0.55, and you said it was 33.
33.36.
Okay, and again, that was my number, and it should hopefully make sense that this angle would be 33.36.
701297.
Now, here's the bad news about doing stuff like this.
Uh-oh.
There is, in certain situations, and this is stuff we're going to talk about Monday and Tuesday and so on. There's certain situations when you start a problem that you could have different answers than what the book has, because it goes off the acronym system that we had in geometry class. That certain, yeah, like
Angle, side, angle.
angle, side, side, those markers. When you're doing oblique triangles that are random, there is a potential where, like on this picture in particular, this problem could have a completely different solution because of the acronym I actually provided you, which I'm going to put on the board, and I know people are going to snicker at it.
Do it, the A.
It's the inappropriate one.
The HL
Okay.
theorem.
Okay, HL theorem, you're absolutely right. Okay. That's the only reason why you memorized that, didn't you? Alright.
It's the only one.
When it's the inappropriate acronym, this picture in particular, this problem in particular actually has different solutions. It has potential to have them. What I mean by that is something we're going to talk about next week, is if you have the inappropriate acronym and you find an angle.
You said that, like in geometry, you always said the inappropriate.
When you have that, and we find our angle, you can actually do a little trick. We can do a little trick, and this angle could be larger. In fact, the picture may be drawn not to scale, where this is B, or sorry, C. Where this is C, and this is A,
Alpha.
and this is little a, where this is the 10, and this is the 30. So instead of having a 33.6, this angle could be huge. It could be like 140s. In fact,
Would it be 189?
no. 180 minus the 33.36.
Looks like a 400.
This angle here could be a 146.64, and that's something we're going to talk about on Monday. Why can that be one of the possibilities? Why can your angle be really, really obtuse, but my math and my calculator says it has to be 33.36? Like, why is there two different answers? That's something we're going to talk about Monday, that there is that option where some of these problems we're going to be working on have two sets of answers, like this. There's two sets. It's easy once you understand the rule. So once you see it, like today was to introduce how you combine walls using proportions and those trig functions on non-right triangles. But what we're going to talk about Monday is what happens if there's two sets. I think this stuff is easy. Like
You also
way,
went to college for this.
yeah, but no, I'm saying that this is way easier than the last of these.
Yeah, that's true.
Good thing we're not taking a
Significantly
test over
easier.
this.
This is pretty easy stuff.
Okay, all right. I'm going to leave this on the board today. If you haven't written the examples down, you should. You're going to get the remaining 20 minutes today to work on your assignment. I'm going to put the assignment back on the board here in a minute. What?
Why are we going straight to this chapter?
Because I want to finish all the trig function stuff.
Oh, so we're not doing the last chapter?
So after we finish all this stuff, we're never doing the final
Yes,
one.
but there's the two sections we're doing in chapter 6.
We never
We
talked
add
about
on
it.
on
So
that.
the test will only be. So what is the hardest chapter we will do?
Yes.
What is the hardest chapter?
So no test.
Or do you have yours?
So no test. I'm doing good.
Yes.